Okay, and then okay, this is one of those native footprints. This is a footprint of a late hominid in Australia from a place called Willandra Lake. It's a very unusual looking track, and I'll show you some photographs of that. And then this is a brown bear, a grizzly bear. And they're all just drawn to the same scale. Then just simply superimpose them to see what's the overall agreement in their shape. And you can see that the moon bear has, I mean, there's some aspects of the general dimensions of the pad that are similar, especially like this contour, which is kind of distinctive. Excuse me. But the toes on our Ngoi room, it lacks that real evident triplet, really. You know, there almost is, even discounting the relative size, or the enlargement, the artifactual enlargement of the big toe, there still appears to be a differential big toe and a toe row. And so in some ways, and you know, maybe I'm reading too much into the appearance of claws here, and so in some ways it actually fits the appearance of the indigenous tribal person here, except for the lack of this. This bulge on this size corresponds to a bony process on the calcaneus that is much more prominent in a bear. It's called the peroneal tubercle. It sticks way out, and so it often gives that curve to the inside edge of the hinder part of the foot, in contrast to the human condition. Okay, what about the possibility of mainland orangs? Well, if it is an orang, it's adapted in a much different way. You can see that the extant orangs on Borneo and Sumatra are highly evolved for quadrumanous climbing, four-handed climbing, and their foot essentially functions like a hand. Their big toes way back here. It's often very reduced in length. In fact, sometimes they don't have that last bone. And there's no nail whatsoever. There's just a stub there. You can see on this individual the relatively long claws. Long nails. Keep me straight there. What about Homo erectus? Could Dr. Viet be on the right track? Well, the only Homo erectus footprints we have are pretty few and far between. The most recent and having received the greatest attention are a set of tracks from East Africa, from the site of Illeret. And this one you can see is very deep. You can see the toes going in there. This is the cover of, this figure was on the cover of Science magazine, and actually very few, I can guarantee you that probably 80% or 90% of the readers didn't have a clue of what they were looking at. I even had to sit and stare at it for a while because I was trying to, given the scale, I was trying to, or lack of scale, I was trying to interpret toes here, and then this would be the instep and the arch, you know, back over the heel back here. Well, that's not it at all. Here's one footprint right here, big toe, no lateral toes showing up, and then here's the outline. Here's the other, here's another right imprint. Big toe would be there. Here's the, so there's two individuals, unless he was hopping along there on one foot, and then right. And see, I have to look again. Right. Oop. Right here. Here's another big toe. And here's the outline. Down here, the heel's partly obliterated. And of course the researchers looked at this and said, well, they look just like modern humans, they have a well-developed arch. Not so fast. Okay. Not so fast, because right here we have some sort of ungulate, a split-hooved ungulate, antelope or something, whose track has disrupted the footprint. This is all extrusion around the hoof print that's superimposed on the hominid print. Likewise, this right here is a hoof print, and this whole bit right here is extrusion from that deeply impressed hoof print. So what they're interpreting as a raised medial arch is just nothing but an artifact of an overstep by an antelope. In reality, it has flat, flexible feet, as you can see right here. There's no indication of an arch there. There's no differentiation of the ball to speak of. And even this, here's a hoof print here, so even this contour is artifactual. You can't rely on that interpretation. So my argument about the combination of non-divergent toes with flat, flexible feet is further vindicated by these. So we have from the earliest hominids all the way up through about 1 million years ago, hominids were successfully walking around on flat, flexible feet. Just like the Sasquatch are adapted, but adapted to a lighter weight. And that's further corroborated by the foot skeletal elements, few though they may be. This is the bone at the base of the big toe in a Homo erectus or a differentiated ball, and sporting very long digits, exceptionally long digits. So, Neanderthal footprints, could it be a relic Neanderthal? Well, here's one of the best Neanderthal footprints we have. They're really quite modern in their aspect. They differ from us postcranially primarily in their greater robusticity, density of cortical bone. So we can superimpose a modern human foot, and in this instance, which is just an arbitrary example, the main difference is in the degree of splay of the toes. So Neanderthals being unshod, much like the native in Southeast Asia, whose foot would look much more like a Neanderthal's than ours would. The prospect of relic populations of Neanderthals on the globe, particularly in the Altai, Tien Shan, and the Caucasus mountain ranges, has been investigated by Dr. Mary Jean Kaufman, who's still with us barely, but I'm trying desperately to connect so that we can do some work with her footprints, but she has a series of footprints. Whoop, sorry, I'm not very good at doing that without a pointer. Dr. Krantz and Dr. Dmitry Bayanov there in pictured. She has a collection of footprints attributed to the Almasti, and they are, in all respects, more human-like. They just look like a very robust, barefoot, habitually unshod human footprint that are being found in very remote places in these mountain ranges. Here are some of the first tracks from China that I came into contact with. These were brought back from China by the late Richard Greenwell, who directed the Cryptozoology Society. Not the best examples, not a lot of anatomical detail, but the outlines and proportions are fairly consistent with those of opportunity to go to China to meet with some witnesses, one of which was Mr. Yuan. Mr. Yuan had been a soldier in the Red Army at the time of the government-sponsored expeditions to the Shenjians in Hubei province back in the 70s under the direction of Dr. Zhou Gujing. And he liked the area so well, he stayed on as a park ranger. While he was a park ranger there, he was out on walking a circuit, and coming up a ridge on the opposite side of the head of this valley, he saw there was a large boulder, and on the boulder was lying this red, hairy figure. And he wasn't sure what it was. It just looked like a lump of fur, so he shouted at it. It sat and turned and looked at him with a flat face, human features. He was probably at a distance of maybe 150, 200 yards. And then it slid off the rock and walked away into the rhododendron bushes on 2 legs. So he hiked on up, hustled up around the head of the canyon, and pursued it, and found a place where it had 2 exquisite plaster casts. Now look at the remarkable convergence here. Lighting, because it was an overcast day, that you can see the pressure ridge right here, 5 toes across here. It's a remarkable congruence or convergence on the example from the Patterson-Gimlin film site cast by Bob Titmus. Here you can see it in place of register overlapping bear tracks or something like that. It's one contiguous footprint with a very distinctive pressure ridge. Profile is, I thought I had the other, I guess I did. Now, for want of time, well, we're okay. Some people have taken exception to this whole notion of the mid-tarsal break. And one that has gotten a bit of traction on the various, this experiment conducted by Matt Crowley. And to his credit, I mean, he's out there doing the experiments. You know, but it's one thing to do the experiments, and it's one thing to have the wherewithal to interpret the results. So I praise him for his initiative in going after these things. But he made himself a pair of rubber footprints, and he thought that you could get something like this just by using a flexible rubber prosthesis. And sure enough, you know, walking in sand, he did kick up some pressure-release discs. But notice the position; it's inconsistent. You know, the deepest point's right here on this step, and it's over here on this step. Pressure ridge peaks right here, peaks right here, and it's just throwing back a succession of pressure discs. That's indicative of sort of an amorphous skeletal anatomy and the joints within that foot skeleton. And that's where he fell short in his internal structure. It's interesting now that I know I've been saying, and this is largely a result of my preoccupation with the Sasquatch question, providing fresh perspective to reevaluate some of the hominid fossil record, particularly the footprints. And as a result of the observation of similar types of artifacts in early hominid footprints, I've argued, and based on the analysis of footprints, studying gibbon locomotion, says we have some fossil remains of hominid feet, and those indicate that our early ancestors had floppy, flexible feet. Okay, there's one, and then with the hobbit, a very good foot skeleton is preserved, a very long foot skeleton relative to lower limb length, and it shows features that are remarkably primitive in terms of a very flat foot with weight-bearing indicators on this large navicular tuberosity, so this inside edge. It has a very short big toe relative to the other digits, which indicates that it couldn't be incorporated into an arch. You know, if those of you who have second, you know, we were talking about having longer second toes, one of the side effects often of that is that the second metatarsal, this bone right here, is also longer. And that causes problems because it takes weight. But look at the difference in size and robusticity between those two. It's not designed to take the weight at the lead edge of an arch. And so you get pain in your foot. You build up this unusual callus underneath that and get tenderness under there. So Jungers, who led the team that analyzed the foot, and I was unfortunately excluded from that, but that happens. But Jungers said that he found that Homo floresiensis had a short big toe and flat feet, and was probably a poor runner who walked with a high stepping gait. Okay, so here is a hominid that dates to 18,000 years ago. So it's been around for potentially its lineage for about 7 million years, walking on flat, flexible feet. No precedent for flat, flexible feet, and well, they're singing a different song now. Unfortunately, I'm not being cited as the source of the information, or that doesn't matter. Just the fact that we now have, an expert cannot appear on camera and say that it just doesn't make sense to have a Sasquatch foot with a non-divergent big toe but retaining flat, flexible feet.